Okay, so here is the number question portion of the exam review. So our first question in our practice exam is going to be a fill in the blank question. So it gives us a quantity of 0, 1, 2, 3, 4, 5. Need to extend my graph a little bit. And then it's going to fill in some of those blanks and ask us to come up with the rest. So for our first one, it gives us a fixed cost of 70. So we know that that fixed cost is going to carry throughout because fixed cost doesn't change based on quantity. So we can go ahead and fill all of these in to be 70. And some of them look like 20 because my handwriting's bad, but that's okay. Just fix that. Alright, so the next thing it gives us over here, there's an 80 on the variable cost for 2, a 120 on total cost for 1, a 30 on marginal cost for 3, 37.5 on average variable cost for 4, and 54 on average total cost for 5. There are a few things that are important to know for this. Fixed cost doesn't have quantity attached to it. Variable cost does. Total cost equals fixed cost plus variable cost. Marginal cost equals the derivative of total cost, or in some cases it'll equal the slope. So sometimes that's going to be variable cost 2 minus variable cost 1 over quantity 2 minus quantity 1, and that works when you have a linear cost curve. Average fixed cost equals fixed cost divided by quantity. Average variable cost is variable cost over quantity, and average total cost is total cost over quantity. Yeah. So our next thing is to figure out the rest of these costs. So variable cost is based on quantity, but here we have a quantity of 0, so our variable cost is also going to be 0. So our total cost is fixed cost plus variable cost, so that's 70. Our marginal cost is going to be the difference between the cost here and the cost of the previous quantity, but here we have 0, so our marginal cost just doesn't have a value, neither does these ones because you can't divide by 0. So for our first one, fixed cost plus variable cost equals total cost. So if FC plus VC equals TC, then 70 plus X equals 120, so 120 minus 70 equals X, and 120 minus 70 equals 50. So next is our marginal cost, and again, that's going to be the difference between our total cost, our variable cost previously, it's going to be the difference between our total cost previously and our total cost now. So our total cost previously equals 70. We got 120 minus 70 divided by 1 minus 0. So the only thing you have to remember in this case is that you have to keep the numbers in the same spot. If you did 70 minus 120 over 0 minus 1, that would also work, but you can't switch a different way. So 120 minus 70 is 50. 1 minus 0 is 1, so we have just 50. And that's one of the easy parts for marginal cost in this sort of format because we're only increasing by 1 unit. So we don't need to do any like fancy division because it's just over 1. You can really just subtract them. Our average fixed cost is fixed cost over quantity. Our fixed cost is 70, our quantity is 1, so AFC is 70. AVC is variable cost over quantity, and 50 over 1 equals 50, and same for average total cost, where there we have 120. So for the second one, our given number is 80. We know our fixed cost will be 70, so our total cost is our fixed cost plus our variable cost. And 70 plus 80 equals 150. Our marginal cost is the difference between our total cost here and our total cost here. 150 minus 120 equals 30. Average fixed cost is fixed cost over quantity. So 70 over 2 equals 35. And then average variable cost is variable cost over quantity. 80 over 2 is 40. And then our average total cost is going to be total cost over quantity. 150 divided by 2 is 75. So for the next one, our variable cost, it gives us marginal cost, and it wants to know variable cost, total cost, and these three over here, AFC, AVC, and ATC. So if our marginal cost is 30, that means our total cost plus marginal cost, our previous total cost plus our current marginal cost equals this number right here. So MC equals TC2 minus TC1. So if we have an MC of 30, 30 equals TC2, which is X, minus TC1, which is 150. You can just add 150 to both sides. So 150 plus 30 is going to be our total cost for this quantity, for the quantity of 3. So 150 plus 30 equals 180. So we know our variable cost is going to be our total cost minus our fixed cost, so 180 minus 70, which is 110. Our average fixed cost is our fixed cost divided by our quantity, so 70 divided by 3. So you can just put 70 over 3, or you can solve that out further if you want to. On the test, it's not going to make a difference. I'm just going to put 70 over 3 because it's a repeating decimal, and I don't want to deal with it. Our average variable cost, again, is variable cost over quantity. So 110 over 3, and average total cost is total cost over quantity. So 180 over 3 is something we can solve out, and that's 60. So in the next case, it gives us average variable cost, and AVC equals variable cost over quantity. So AVC is 37.5. 37.5 equals variable cost over quantity. We have quantity. Quantity is 4. So we just have to times both sides by 4. So 37.5 times 4 equals 150. So we know that our variable cost equals 150. And variable cost plus fixed cost equals total cost. 70 plus 150 is 220. Marginal cost is going to be the difference between our total cost now and our previous total cost. So 220 minus 80. And 220 minus 80 equals 40. Excuse me, 220 minus 180. Now our average fixed cost then, fixed cost over quantity, 70 over 4, that's 17.5. Average total cost is going to be our total cost over our quantity, so 220 over 4, which equals 55. So in the next case, we only have average total cost, so 54 divided by 54 times 5 equals total cost, because ATC equals TC over Q. We know ATC, which is 54. We know Q is 5. So if we multiply by 5 on either side, then that's going to give us our total cost. So we know that our total cost should be 270, and our total cost minus our fixed cost is our variable cost. So 270 minus 70 is 200. So that gives us a variable cost of 200. And then MC marginal cost is going to be the difference between 270 and 220. 70 minus 20 is 50. Average fixed cost is our fixed cost divided by quantity. 70 over 5 equals 12. Our AVC, 70 over 5 is not 12, it's 14. I don't know why that's incorrect. Okay, our AVC is going to be our variable cost divided by our quantity, so 200 divided by 5, which is 40. And then we have our ATC of 54. Okay, so that's it for this question 1, and this question will be on the exam, I believe. At least it was on last year's exam. Each blank is worth half a point, usually for a total of about 12. But yeah. So I'm just going to erase this, and then we can move on to the next question. Okay, so here's question 2. Question 2 is an M method question. It has 3 parts. So we have part 1, which is a production function Q equals L plus 2K. The second one is Q equals L to the 0.5 times K to the 0.6. The third part is Q equals L to the 0.2 times K to the 0.3. Alright, so for the first one, we're going to put an M in front of each variable. So ML plus 2MK. And we can pretty much already see from this that however we're combining the m's because it's addition, the highest value we're going to get is 3m because we've got 2m here and m here. And 3m is only to the power of 1 because when a number doesn't have an exponent on it, you know that that exponent is actually 1. And for the m method, when we have an exponent that is equal to 1, we have constant returns to scale. If the exponent is greater than 1, we have increasing returns to scale. And if the exponent is less than 1, we have decreasing returns to scale. So that's as far as you can see for that one, and it's pretty easy to just pull these m's together. The goal of the m method is just to move the m's as together as you can possibly get them and then judge the exponent on it. So for the second one, ml to the 0.5, mk to the 0.6. So we've got m to the 0.5, m to the 0.6, and when you multiply, because this is multiplication, when you multiply these over, m to the 0.5 and m to the 0.6 is going to be m to the 0.5 plus 0.6, and that's just one of the exponent rules. 0.5 and 0.6 added together is 1.1, so m to the 1.1. 1.1 is greater than 1, so we have increasing returns to scale. So for question 3, we have L to the 0.2, K to the 0.3. So M L to the 0.2, M K to the 0.3. And we can do the same as we did over here. So we've got M to the 0.2 plus 0.3, which is 0.5. So this is M to the 0.5, and that is less than 1, so we have decreasing returns to scale. So a little tip for the quiz and stuff, if you see, or for the test, if you see a square root sign over an m or over like a party that m is involved in, that's the same thing as m to the 1/2. So right here, m to the 0.5, this can also be written as square root of m. Also, if you have to square root something and you don't have a calculator that can do it, or if you have to like quintuple root something or whatever, like 4th root of blah, 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 blah. If you put that number to the power of 1/4, that's the same as saying a 4th root. All right, so that's everything we need from question 2. Tangency condition, it's a little bit easier to remember than this first part right there. So we use the tangency condition because it's harder to mix up. So MPL over W, MPL is 2LK squared. And we're going to put that over W, which is 2. and that is equal to 2L squared K over 8. Now we can use our like cross multiplication when we have a fraction equals a fraction. So that's going to give us 2LK squared over 2L squared K, and that is equal to 2 over 8. I like to expand these because I'm not very, it can be sometimes hard to visualize it. So we have 2 times L times K over 2 times L times L times K. So we can get rid of a K, get rid of an L, get rid of a 2, we have K over L. So K over L is equal to 2 over 8. And we want to get one of these things by itself. We'll get we'll get L by itself, excuse me. So times L times L. K is equal to 2 eighths L times 8 times 8. So then we have 8, K is equal to 2L, divide by 2. 4K equals L. So for part C, right, this is part A, this is part B, part C right here. L equals 4K. That's our optimal choice for substituting. So the next part, part D, is giving us a certain amount of units. We have 2,560,000 units. And we want to find out the optimal K and L to get that output. So we're going to set this equal to our original production function up here. So L squared, K squared. And then we can take this a step further because we know that L is equal to 4K. So 2,560,000 is equal to 4K squared times K squared. So we can do some things with this. First of all, we can combine our like terms, and that's going to give us 16K to the 4th, because 2 times 2, so we can pop this one, right, and make that a 16 to get rid of that 2, and then we combine it with this one, so we get 16K to the 4th. So 2,560,000 is equal to 16K to the 4th. So now we can take the 4th root of both of these things. The 4th root of 2,560,000 is 40. And the 4th root of 16K to the 4th is 2K. The 4th root of 16 equals 2, and the 4th root of K to the 4th equals K. So 40 equals 2K, so K equals 20, and L equals 4K, so L equals 20 times 4, which is 80. So we know to achieve 2,560,000 units of production, we need 20 hours of capital, 20 hours of labor. And we can go back further and say how much is this going to cost us. It's not required for this, but we can go ahead and do it. And we'll plug that into our cost function. C equals 2L plus 8K. So 2 times L, 2 times 80 is 160. 8 times 20 is also 160. Let me just double check that. Yeah. So C equals 160 plus 160, C equals 320. So to make 2,560,000 units, it will cost us $320. And that is the extension of the number questions for the exam. I would expect for each of these types of questions to be on the exam. I definitely know that question 1 with the fill in the blanks and stuff, that was on the exam last year and the year before. So are the in-method questions, and remember, if you don't use the in-method, you will be docked points. You need to use the in-method. Don't use any sort of guess and check or whatever, plug and chug sort of thing. Like, please use the in-method. The easiest exams to grade are the ones that are all correct. Okay, so that's all I have for you for the number stuff. Yeah. Have a great day and do well in your exam. Good luck.